This lesson took place in May of 2021. This is a high flex class, so there are students both in front of me and online. My students learned about Bohr models as well as how to identify the valence and core electrons on these Bohr models on the previous day. This lesson tries to connect the concepts from the previous day's lesson with real-world observations, in this case, the behavior of alkali metals when they react with water.
The reason why we make valence electrons a special thing, like we say that valence electrons are the outermost electrons, right? And then core electrons are just everything else. The reason why valence electrons are so special is because they're the most involved in the chemical reaction. So atoms can gain or lose valence electrons during a chemical reaction. That's why we say that they're like, we give them a special name. I'm going to be showing you a video in which lithium, sodium, and potassium react with water. So lithium, sodium, and potassium, they're all in something called the same family. And so they have similar characteristics, similar qualities about them. Be prepared to write down your observations and be prepared to have questions about this video, okay?
In addition to showing them a video of lithium, sodium, and potassium reacting with water, I also had sodium in the classroom to use in a demo.
What I have in this is sodium metal, and you guys are probably thinking, isn't that the same thing that I use for table salt? And when I show you sodium metal, you're going to be like, oh, that is definitely not it. So inside of this container with sodium is all these little grains, and they absorb water because, as you saw, when sodium reacts with water, it could get kind of messy. I'm just going to come around and show you guys that how easy it is to cut into it.
I walked around the class and let them look at the sodium and show them how easily it can be cut into.
So I'm just going to go ahead and get a little bit of the sodium, and I'm going to try to wipe off some of the oil that's on it. And the reason for that is it just kind of gives a better reaction when you don't have so much of the oil that's on. All right, so like you saw in the video, sometimes sparks do fly. So I just want to make sure I don't have anything flammable on hand. All right, so there you have it. It's a demo with sodium and water. All right, in the meantime, I want you guys to go ahead and answer on Pear Deck. What did you notice? So just try to stick to observations you made with your 5 senses. Resist the urge to make conclusions at this time. And what are you curious about? Can I get some volunteers to talk about what did they notice from this reaction between sodium and water?
At the fire, when you put the thing in it, over the time it sparks more and more, and then it just pops.
It starts to spark more and more, and then it just pops.
It just explodes. Yeah.
Okay, interesting. What else do people notice?
I noticed that it's not an instant reaction. It's first it takes a while after it starts getting into flames, and a while after it getting into flames, it starts little explosion, and after that little explosion, it starts big.
Yeah, it kind of builds up. So it's starts small and then it explodes at the end. What else did people get? Well, what else did you guys notice kind of formed in that whole reaction? Did you guys hear something or see something else besides just flames?
Smoke. Yeah. Smoke.
Yeah, you guys probably saw some gas building up. What else? Did you guys hear something?
Yeah.
What
At
did
the
you
beginning was when you put something really hot into water, or the other way, water into something really hot. Those
Okay, so Miguel said when you put water on something that's really hot, it makes that sizzling sound. If you put a steak on a pan, it makes a sizzling sound. What is that sound from?
the operation.
The
What was the
The operation?
No, evaporation. I said that.
Evaporation. Yes, so something is turning into a gas, right?
Yeah.
So now let's talk about questions. What questions do you guys have? Samuel, what question that is? What is one question that you have?
It should be like, uh, how does it like get the reaction with water?
How does it react with water?
Yeah,
Okay.
because it doesn't emit any flame or something like that.
Does it
Water.
emit any flames?
Yeah, so that's kind of cool.
Okay. Amina, did you have a question? Or something you're curious about?
I said, does temperature increase during the process?
Does the temperature increase during the process? Interesting. I think I'm not entirely sure. I think maybe it does, but not. I didn't really add that much sodium into it. Can someone online give us a question? Eric, did you say something?
No, but like, thanks. I put a question for them. Because of the reaction doesn't mean that it has like more protons or electrons, neutrons.
Like what is the thing that changes during the reaction?
Yeah.
Okay. Jules, can you also give us something?
I got a question.
Well, what's something that you're curious about?
Would there be more smoke if you put a bigger piece?
Would there be more smoke? Did you guys see that one where he chucked the whole thing into the lake?
Yeah.
Jules, can you give us something that you're curious about with the reaction between sodium and water?
Maybe like, does it react the same way with any other liquid?
Ooh, does it react the same way with any other liquid? Well, it doesn't react with oil, so that's one thing out of the way. I wonder what would happen if we got alcohol and made it react with alcohol. So the reason why you do not want to do that reaction with alcohol is because it's actually going to be a lot more dangerous.
Why?
Do you guys want to guess why?
Why?
Because
Well,
alcohol is
okay.
like, it can get fire too easy.
So, okay, based off of what Miguel said, does somebody want to like kind of build off of that? Like what would happen if this was a beaker of alcohol instead? Okay, what about this? Can you talk with maybe a partner or like maybe with a small group? What would happen if instead of a beaker of water, what would happen if this was a beaker of alcohol and I put sodium in there? So I heard some people saying that this whole thing would just catch on fire,
It
right?
would explode. The glass would explode, or the glass explode.
Okay, so it might explode and then that's gonna cause some fire, and then alcohol is flammable, so then this whole beaker is just gonna catch on fire. Like this, everything inside this beaker is just gonna burn. Like I'm just gonna have a beaker full of fire if this was alcohol. So that's why I don't think I wanna do that with alcohol, but I'm perfectly fine with doing that in water. Yes?
What's the difference between the salt and the sodium?
I think that's a really great question. Okay, so that's when we get into kind of explaining what exactly is the difference, because you guys know sodium, right? You eat sodium. Sodium is in your food, like sodium is in your table salt. What the heck was this thing that you just saw? Like, why is that also sodium? Are you guys kind of wondering, like, what the heck is going on here? Well, there's two different kinds of sodium. So what did we have in the beginning? What did it look like? So what did this sodium in the container look like? It was
Like spongy? Not
kind of,
spongy.
yeah, like really soft.
Yeah, softer.
Soft. What else?
Gray.
What's that?
Color gray.
It's like gray, like silver, even. What else did you guys notice about that sodium?
It was like slimy.
Slimy. Oh well, that's from the oil. That's from the oil.
Really solid.
It was a solid. What else do we have?
It's a compacted thing.
Yeah, it's like compact. It's like squished. It's like a metal. It's a metal, but it's just like a soft metal. I put the sodium in here, the sodium metal in here, right? Is it gone? Did it just disappear? Or is it still in here?
Still.
Okay, let's take a vote. How many of you think that there is still sodium inside of this liquid? Like, as you can see, it's clear. Well, kind of. How many of you think that there is sodium inside of here? Okay, how many of you think that there is no sodium inside of here? It's very, very confusing. It's clear. Like, maybe it evaporated into the smoke or something. I'm not sure. There is sodium inside of here, but it's a different type of sodium, right? So what does this sodium look like?
I can see it.
Yeah, you can't see it. Can't see it. What else does it look like?
It's clear.
Like,
It's
It's
a liquid.
a liquid. Like it's yeah, kind of liquid. It's well, like when you put sugar inside of your like tea or something, does it just disappear?
Dissolved.
It dissolves. That's the exact same thing that happened with the sodium metal. It dissolved. So what happened when I reacted the metal with the water?
yeah, it goes.
Reacted with water. It was kind of unstable even, right? It's unstable. Alright. This one, it's in water, right? Is it doing anything or is it just minding its own business? Yeah, like this is perfectly safe. Like this, like I would have no problems with it. And it's not doing anything because, well, it's stable, right? Okay. So I think maybe we're kind of getting the idea that there are two different types of sodium. Sodium that is the metal type and sodium that looks kind of like this, right? So here is sodium. I'm gonna call on people to give me some observations, all right? Callie, are you there?
Yeah.
Okay, what do you observe about this structure of sodium?
Was I don't know, the valence electrons just add one.
There's one valence electron?
Yeah.
Okay. Can I get someone else to give me another observation that they noticed about this?
Unstable.
What's that?
Unstable.
Unstable? And why is that? Because,
The outer energy level is not full.
yeah, because the outermost energy level is not full. It does not have a full octet. Okay. Which sodium do you think? Oh, and did you guys also notice that it has a neutral charge? Same number of protons as electrons. It's neutral. Do you think this belongs to the metal or to the dissolved one?
Metal.
Okay, how many of you think that the metal one is the one that's neutral? I'm asking, so this is the model, Bohr model of one of the sodiums. And I'm wondering if you think that this belongs to the sodium metal or to the sodium that's dissolved in water. Well, you're supposed to know by looking at if it's unstable or if it's stable. Okay, how many of you think that this, the one that's neutral, is the metal one? Okay, how many of you are like not really sure? Okay, well this one, as you can see, it has one valence electron, so it doesn't have a full octet, right? So it's unstable. So now you have to decide which one of these was the most unstable. The one that's being kept in this container, or the one that's like, meh, doing its own thing. Yeah, so it's the one that's being kept in the high security container, that's the unstable one. So the one that's in here has a Bohr model that looks like this. How do I make the Bohr model that looks like this? What do you guys think happened? Take a couple of seconds. How do I change this Bohr model from the metal one to the one that is dissolved in water? Take a couple of seconds. Maybe, can you talk to someone next to you? Take a couple more seconds, sorry. Just discuss anything. Make sure that everybody's on the same page. So I'm getting some responses. Can I get a volunteer to raise their hand and tell me what they think? Yes, Miguel.
So, we said that maybe taking the valence electron, like take it out,
Like,
now we have a full octet. Yeah.
so like that.
Yeah, so now it will be like more stable.
So now it has a full octet. Okay, how many of you agree with Miguel? Okay, how many of you are also kind of lost? Okay, I agree with Miguel. So the one that has a full octet has a Bohr model that looks a little something like this. All right, so that's the one that has a full octet, is stable, and is dissolved in water. Or
It has a positive one charge too.
yes, it also has a plus, it's charged. So I'm gonna kind of quickly introduce a new word to you guys, so I'm gonna be explaining more tomorrow. Whenever it's charged, it's something called an ion. So I just want you guys to summarize what you have learned. Summarize some of the differences between sodium metal and sodium ion on Pear Deck, all right? I just wanna make sure that we're all on the same page about this. So everybody should be on Pear Deck, writing down what are the differences between sodium metal and sodium dissolved in water.
This is our closing Pear Deck slide. It asks students to summarize some differences between sodium metal and sodium ion or dissolved sodium. I received some good responses such as the following. Some simple but still correct responses, and some from students who were a bit lost. In the following day as a due now, I revisited this topic by asking students, how does sodium get a full octet? Thank you so much for watching.